saying, guys, it's not always going to be, they're not always just going to give you the apothem and the side. So uh, basically, we're going to create a right triangle. So like I said, right triangles are not going away with the apothem and the radius. Okay, so just like we had up top, we're going to have a right triangle again, and that way, so up here, we had our right triangle right there, okay, right up here. So since we have the right triangle, we're going to use trig to find the side lengths, okay? Now, you can also use special right triangles. It's a faster way, but again, trig, if you prefer trig, because I know we struggled with special right triangles, so you don't have to use them at all. You can use trig the entire time. It's just special right triangles is a shortcut, all right? It's a shortcut. So to do this, they have a little, like 3 steps for us. So looking at number 3, we're going to create a right triangle by drawing the apothem and the radius. So here we have apothem, go to radius, all right, have our right triangle there. Sorry, that's not great. But then we have to find the measure of the interior angle where the radius intersects the vertex, okay? So where the radius intersects the vertex. So all we do is we use the interior angle, so the n minus 2 times 180. So for this one, it is going to be when we do the 6 minus 2 times 180. That gives us, I think, 720, and then we divide by 6. I might be wrong with that, that's 720. But I know this angle over here, just because I haven't memorized at this point, is 120 degrees. All right. So that is 120 degrees because we divide that by n, okay? So, yeah, so it is 720. We divide that 720 by 6, and that would give us 120 for that angle right there, okay? So then all we have to do, and this is the trick. This is the part that you're going to use a ton, okay? So I hope we understand this. So that's back to like chapter 6.1, okay? Finding that 120. What we're going to find here is we are going to find this angle right here, okay? That angle right there, okay? That angle has a relationship to this 120, okay? All it is it's half, okay? It is just half of the vertex angle. So first step, find the total sum of the angles, divide it by the number of sides, and then find that angle made by the vertex and the radius there. And that angle is just going to be half of the total vertex angle. So for this one, we take that 120 and we divide it by 2, and that gives us 60. So that is going to be, that angle right there is 60 degrees. Okay, it's 60 degrees. So now that we have that, we're just looking at a right triangle where we have, here, running out of space here. Coming up here, this side is 5. This degree of this angle is 60 degrees. And what we're going to need to find, and this is where we're going to try and find the perimeter, because we don't need the radius. So I hope you guys understand that. We don't need, if we're looking at our right angle, we don't need this side over here, okay? That side, the hypotenuse over here, we don't need that. We need this side up here, all right, to help us find the perimeter. So when we do that for this one, okay, we can do it 2 different ways. If we have this, we have a 30, 60, 90, okay? 60 is opposite the 5, so we could just divide by radical 3. Now we could also use trig, okay? We could also use trig, and since it would be tangent, so we would say tan, because it's opposite. 5 would be the opposite side. X would be the adjacent side. So tangent of